Please put your attendance in the command window. Okay, students. In the last class, we have discussed Rankine formula 1 problem, and it is the second problem. And here we are also comparing the Rankine's equation with Euler's equation. Both these equations are known to us. We have already taught or studied different equations. One is for long column and other one is applicable for any kind of column. So please write down the problem. Compare the crippling loads. Please write down the problem. If you are able to copy the problem from the slide, please copy that. I am reading this problem only for your reference. Compare the crippling loads. Compare the crippling loads obtained. Compare the crippling loads obtained by using Euler's formula. Euler's formula for a steel column. For a steel column, 2.5 meter long, 2.5 meter long, and outside diameter 40 mm, comma, inside diameter 30 mm. Outside diameter 40 mm, comma, inside diameter 30 mm. First up, both ends are hinged. Both ends are hinged. Both ends are hinged. Hinged വേറൊരു വാക്കാണ് pinned ട്ടോ. Both ends are hinged. Full stop. Take sigma c equal to 330 Newton per mm square. Take sigma c equal to 330 Newton per mm square. Rankine's constant 1 by 7,500. Rankine's constant 1 by 7,500. Rankine's constant 1 by 7,500, comma, E is equal to 2.1 into 10 raised to 5 Newton per mm square. E is equal to 2.1 into 10 raised to 5 Newton per mm square. 2.1 into 10 raised to 5 Newton per mm square. First up, also calculate minimum length of this column. Also calculate the minimum length of this column, minimum length of this column for which Euler's equation is applicable. 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 Hope you have written the problem. And now we need to solve this problem. For that, first of all, we must understand what are the given data. Please read the question carefully because from this question we want to get the given data. While reading the first statement, you can understand that length of the column is 2.5. It is not effective length, it is the length. So first of all, we must know what is effective length. For that, we must identify the end condition. When you look the problem, you can understand that both ends are hinged ends. That is pinned end. If a problem with both ends are hinged, what will be the effective length? Please someone
L.
answer. Yes, L. Is it?
Yes, sir.
Okay. Then LE will become L. So the effective length will be 2.5 meter long. That should be converted into mm because all other terms, when you are looking other terms, that is sigma c, Young's modulus, everything given in Newton per mm square. So you need to convert it into mm. That is 2.5 into 10 raised to 3 mm. Then outside diameter DO is given as 40 mm and DI is given as 30 mm. Then sigma c is given as 330 Newton per mm square and Rankine constant alpha. Alpha is given as 1 by 7500 and Young's modulus E is given as 2.1 into 10 raised to 5 Newton per mm square. These are the given data. First of all, you need to write all these data. Now you need to write both the equations. First one is sorry, equal length. We have already studied that for a hinged support, both ends are hinged means LE will become L, that is 2.5 into 10 raised to 3. And we need to write Euler's equation first. Euler's equation is given as PCR equal to pi square EI divided by L square. Before that, please write down if anything pending. You have 1 minute. Please write down whatever you're missing in the slide. Alan, why you didn't join in the last classroom? Alan,
ഒരാവശ്യത്തിന് പുറത്തു പോയിരുന്നു.
every time having excuses. Please be online because it's very important to study all these equations. In last class we have discussed a problem that is very important. Can I change the slide? Can I change the slide?
Yes, sir.
Okay, thank you. So first of all, you need to write the Euler's equation, that is pi square EI by L square, where L is the effective length and E is given. Just compare what are the things which given in the questions. E is known to us, L is given, so only unknown is I. I is moment of inertia. For a hollow cylinder, we know that I is equal to pi by 64 into d o raised to 4 minus di raised to 4. that equation should be first determined. That is pi by 64 into to raised to 4 minus di raised to 4. Don't copy this equation. Just substitute the values and find the value, the answer by yourself. Use calculator. Outside and inside diameters are given in the problem, so you can directly find moment of inertia for a hollow cylinder. The equation is given to you. We have studied this equation from our mechanics classroom. So it's very important equation. You need to study this equation for our future semesters too. So it's very important equation in a mechanical engineering. Are you getting the answer?
Yes, sir.
Okay, hope everyone getting the answer correctly. That is, moment of inertia is determined as 85859.38 mm raised to 4. Unit is very important. You can see that here diameter raised to 4 is the term. So definitely the unit of moment of inertia also will be mm raised to 4. Since all other components are unitless. So after that, you need to determine Euler's crippling load. The equation is given to you. Pi square is known, E is known, I is determined now, and LE, effective length also determined. After substituting all this value, you can see that the value of crippling load or Euler's crippling load is 28443.7 Newton. Or in other words, you can say it as 28.44 kilonewton. 28.44 kilonewton. 28.44 kilonewton. Please write yourself. Don't copy the slide. I am showing it for your reference. You need to submit your notebook after coming to college. I will check your notebook.
സാർ 10ന്റെ പവർ വരുന്നില്ല.
എവിടെയാണ്? മോളെ താഴെയാ?
ആൻസർ
ഒരു മിനിറ്റ്. I will check. ബാക്കിയുള്ളവർ ചെക്ക് ചെയ്തിട്ട് ആൻസറിൽ വ്യത്യാസം ഉണ്ടോ? Can you say? Anyone else?
$28.48 kilonewton അങ്ങനെ കിട്ടുന്നുണ്ട്.
28 point. അത് കിട്ടുന്നില്ലേ?
കിട്ടുന്നുണ്ട്.
I too getting the same answer. I too done with my calculator.
ഓക്കെ. ഞാൻ 10⁵ കാൽക്കുലേറ്ററിൽ കൊടുത്തിട്ടില്ല. കറക്റ്റാ.
Okay. Fine. No issue. Whenever you are making a mistake, then only you can correct it. So it's good to make a mistake. Next time you won't do the same mistake. So it's better. Nice one. So after that, we need to calculate K. Since in our equation, we are in need of K for finding Rankine's constant, Rankine's formula, as we have already determined. So finding K, the same method can be applicable. That is, K is equal to root of I by A. I is already determined by us. First of all, you need to calculate A, area of cross section of the hollow cylinder, and Here they have done directly by closing similar terms. That is, pi is crossed, and 64 by 4 will become 1 by 16, and do raised to 4 in minus do da raised to 4. No need of substituting like this. I copied from there. Better you can do as we have done. I will show you that a is equal to what is a? Determine a first. A is equal to pi by 4 d o square minus d I square. Please solve this one. Find area of the cross section of hollow cylinder. Pi by 4 do square minus di square, and tell me the answer. Tell me the
550.
answer. Bracket is there. You know that. Bracket is there. This is a common equation. Have you got the answer? Area?
Five 549.5.
549.5.
ആ
ഇതിന്റെ ബാക്കി
549.7 അങ്ങനെ കിട്ടുന്നുണ്ട്.
That depends on pi value. If you take pi directly, you will get 550 something. And if you are taking pi as 3.14, you will get this answer. Both are correct. Better you use pi full value, whole value. That's better thing. And you will get area as like this. And after that, you need to find I by a, root of I by a. K is equal to root
12.5.
I by a. So hope you are getting the answer. No need of this type of complication. As we have already determined I, it's just simple by dividing it with 549.5.
സാറ് ഒന്ന് ചോദിക്കട്ടെ, നേരത്തെ പി നമുക്ക് കിട്ടിയത് 2.844. അത് ന്യൂട്ടണില് നമുക്ക് കിട്ടുന്നത്
2 point അല്ല 28 point. This is 28. ഇതല്ലേ?
അല്ല, നമ്മള് ശരിക്കും കാൽക്കുലേറ്ററിൽ ചെയ്യുമ്പോ 2.844 നമുക്ക് ന്യൂട്ടണിലാണ് കിട്ടുന്നത് അല്ലേ? നമുക്ക് അങ്ങനെയാ കിട്ടുന്നത്.
No, if you are doing this equation, you will get this answer. Directly, you will get this answer.
നോക്കട്ടെ.
Once again, please check this one, because don't need to put 2.5 into 10 raised to 3. You can take this one as 2500 directly. Then you can reduce the complexity. ഇത് 2500 വരുവാ?
അത് 6.25 into 10 raised to 6 അല്ലേ? താഴത്തല്ലേ സാർ വെച്ചേ?
ഇത് 2.5 into 10 raised to 3 whole square വരുന്നുണ്ട്. അപ്പോൾ 2500 സ്ക്വയർ വരും.
അങ്ങനെ. ഓക്കെ.
ഇത് ചെയ്ത ഈ ആൻസർ തന്നെയാണ് കിട്ടുന്നത്.
കറക്റ്റ്.
അത് കുഴപ്പമില്ല, നീ ഒന്ന് ചെയ്ത് നോക്കണം. മിസ്റ്റേക്ക് ഉണ്ടെങ്കിൽ നീ എന്തായാലും എന്നാ നമുക്കൊന്ന് വാട്സപ്പ് ചെയ്യണം, കാരണം അത് തെറ്റുണ്ടെങ്കിൽ നമുക്കത് കറക്റ്റ് ചെയ്യണ്ടേ. When you are doing this calculation, you will get 1 minute, pen എടുക്കട്ടെ. You will get root of 8 5, 8, 5, 9 അല്ലേ divided by 549. I think this is the answer. That's correct one. So
സാർ
that,
മനസ്സിലായി തെറ്റിയത്. എങ്ങനെ വെച്ചാല് കാൽക്കുലേറ്ററിൽ 10⁻³ ഉണ്ട് ഞാൻ കണ്ടെങ്കിൽ. അപ്പം ബാക്കിയെല്ലാം
okay, okay. Then no issue. എടാ മിസ്റ്റേക്ക് വരണം നല്ല ഒരു രസമുള്ളൂ അല്ലെങ്കിൽ നമ്മൾ എപ്പോഴും കറക്റ്റ് ആണെന്ന് വിചാരിച്ച് നടക്കൂലേ
correct.
there is no problem. So answer will be 12.5, right? You will get the same value 12.5 mm. K is equal to, it's not K square, it's K. There's a mistake, it's not K square, it's K. And after finding K, you need to check what are the things missing in Rankine's load or Rankine's crippling load. Just compare the equation. P is the Rankine load. Sigma C is available in our question paper or question problem. And area is already we have found out as 549.5. And alpha is given in the problem, that is 1 by 7,500. LE is given as 2,500. And K is given as or found out as 12.5. After substituting all this value, you will get the answer directly. Okay, you will get the answer directly. Please substitute the values and found the answer. I will not give the answer until you complete. Please tell me once you get the answer. Have you got Rankine load?
28692.2.
2869. Okay, no problem. Almost there will be change of pi, I think. Everyone should do yourself. Don't copy. I am showing the intermediate steps for your reference. And some students are doing very excellently. Have you copied this thing? Okay. Now we have found the Rankine load, that is 28.63, and we have Euler's load as 28.44. The question asked is, just look the question, compare the crippling load obtained by using Euler's formula and Rankine formula. So you need to find the comparison, that is ratio of crippling load obtained by Euler's formula and Rankine formula. So you need to take a ratio of Euler's crippling load divided by Rankine's crippling load. That was asked in the question paper, and the answer will be, just look here. Where is this? I just missed that thing. I didn't return that thing. Please copy that one. That is you need to take the ratio of Euler's crippling load divided by Rankine's crippling load. Please tell me the answer once you complete. What is the ratio? 28.44 divided by 28.63.
Point 991.
Yeah, there is a small variation. So you need to write the ratio as 0.99. Even by looking the equation, you can see that the values are very much similar because 28.44 and other one is 28.63. So by looking the problem itself or answers itself, you can understand that both are coming at almost similar value. But the question is not yet over. They have asked also calculate the minimum length of this column for which Euler's equation is applicable. It's a very important term. Can you identify what is the question? In this question, they have asked at what length this column is solved by Euler's equation. That is, at what length that will become long column. Euler's equation is only valid for long columns. So we need to find whether
Sir,
the
screen
given column. Can you hear me?
screen.
Sorry. One minute, 1 minute. Wait for 1 minute. I'm connecting. Can you see the slide?
Yes, sir.
Okay. The last term is calculate minimum length of this column for which Euler's equation is applicable. So we need to find at what length or what is the minimum length required for the column. By looking the values of answer, when you are comparing the Euler's equation as well as Rankine's equation load, you can see that both are coming at almost same value. That means both equations are suitable for this type of problem. So it is by looking the answer itself, you can understand that 2.5 meter long steel column will be a long column. So they are asking what is the minimum length of column for which Euler's equation is applicable. That is what we want to determine. For that, first of all, you need to identify what is the crushing load or crippling stress, this buckling stress. So determining buckling stress, in the previous case, they have given the stress and you need to determine that crippling stress. As we have an equation that is P is equal to pi square EI divided by L divided by K whole square. So divided by that load divided by area. No need of this much calculation. We have load as 1 minute. Load as PCR equal to what is that PCR? PCR is equal to pi square EI divided by L square, right? This is the Euler's equation. So you need to find the stress. As we know that stress is equal to sigma CR equal to PCR divided by PCR divided by area. This is a common equation. Load by area is the stress. So you can find the buckling stress as PCR divided by A. So PCR is determined as 28 443 something, right? What is the value of Euler's crippling load? That is PCR divided by
20.
A area. Please do the calculation and find the value of sigma CR. Directly you can solve this one. PCR found out as 28,443 divided by area is given as area we have found as 549.5, right?
0.05.
0.05. That 0.05.
Sigma CR PCR A.
PCR എന്ന് പറയുന്നത് കിലോ ന്യൂട്ടണിൽ ചെയ്യല്ല, ന്യൂട്ടണിൽ ചെയ്യണേ.
Oh,
28,443 divided by 549.5, right? Correct അല്ലേ? 28,443.72 or 443 divided by what is the area?
549.5.
549.5. So answer will not be this one. The answer will be
51.76.
51.76.
okay 51. Sorry. 51.7 Newton per mm square will be the unit. So from that you need to find L, effective length, or this will be the minimum length required. So finding this one, we need to use this equation. Do you know how this equation came? How this equation came? Any guess? Just simple. I is equal to AK
Cos by അങ്ങനെ
AK square. I equal to AK square, right? This can be replaced here. Here it will become, or here it will become A into K square, and stress, when we are taking stress, this PCR divided by A will be there. So bottom side also will be area this will become sigma. Then A and A get cancelled. The final equation will be pi square E into K square divided by L square. Okay. Or else, no need of these calculation. We found out that sigma CR equal to, what is the value of sigma CR? 51.7, right?
Yes.
Sigma CR is equal to pi square E I divided by pi square EI divided by L square into A, right? Is this correct? I'm asking to you. I'm taking the equation of PCR directly here. No need of this one. This will become complication. No need of doing this one. You can directly solve this one. So we have PCR as like this, and divided by A is the area. And when we are substituting the value of E, I and A and sigma CR, you can directly found L. Actually, it's a special case of problem. They are asking what will be the minimum length required. Can you found? Here, L is the unknown. L is the minimum value required. So sigma CR is found out as 51.7. E is given as 2.1 into 10 raised to 5. I is given as, I is found out as 85859 point something, and area as 549.5. After solving this one, you will get L. Can anyone answer me? What is the value of L? Or else you can do as such, whatever they have given here. This will be complicated than this. They have substituted value of I. Here no need of substituting I. Actually, you can directly substitute the value of I here, and you can find out L square and L. Have you got the answer?
ആ 0.99 തന്നെ മീറ്റർ.
Correct. So if the column length is 0.9 or more, that is 1 meter മുകളിലാണെങ്കിൽ ഈ 0.99 തന്നെ നിൽക്കുന്നുണ്ടോ, then what is the third term? 0, right? 0.999.
0.63 അങ്ങനെ വരും.
Okay, then 0.99 meter is the minimum length of column. That is above this value, that above 0.99 meter, the column will be long column. Below 0.99 meter, the column will be short column. Where in short column, Euler's equation is not applicable. This is what they have asked. So when we are calculating, we haven't considered the crippling stress, because here they have given sigma c, and when we are calculating Euler's equation, there is no term stress. So you need to find stress and back determine the minimum length required for the column. This is the way of solving this. Doubt എന്തെങ്കിലും ചോദിക്കാട്ടോ? You can ask doubt whenever you are having, and when you are making mistakes, don't afraid, because that is good thing. Making mistakes are stepstone for the victory. Please put your attendance in the command window if anyone pending.